Okay, lab time. So hello, everybody. Today we started talking about hydrological issues on the some questions. Oh, it's a separate participation grade. I wouldn't worry too much about it. It's really, as long as you're coming to the labs and, it's to try to prevent dead silence when we ask questions, because we need a little bit of engagement. So, but
If
most
we
people
know,
have been pretty good about that.
That's right. If we know your name, then you've participated.
Yeah.
If we haven't heard your name before, then
that's right.
And there's enough. Thank you, Megan. There's enough people in this class that we can know everybody's name. So
yeah, it would have to be a pretty egregious violation to not get the mark. So like if we've never seen you, then yeah. Yes, so we started talking about hydrological issues. So we're going to look at that in lab, try to sync the lab a little bit with the lecture material. We're going to do it in two parts. As usual. So the first part will be another real world data that you have to go get, bring in, read, start to handle. Actually, Adam, another thing, just in terms of the exploration side, we should probably get them to do a box and whisker plot of the data.
Oh, yeah.
As a way to, it's a nice way to assess the likely distribution. We promised that we would move away from Gaussian distributions, so we're going to do that. The data that you'll be going after are river data. So there's, whoops. Could you, for some reason, I deleted it. Oh, no, I can actually find it here. I'm going to post in the chat.
Need the link?
Well, just all those little instructions, a little block of instructions I sent you.
Yeah, I can pull that. I got it here.
Yeah, okay, if you could just throw that in the... So Adam's going to post a little set of instructions that includes a website where Environment Canada stores all of their historical hydrological data or hydrographic data for rivers. They're real-time data as well, like if you want to monitor the Fraser River and stuff. But it stores the historical stuff as well. So we're going to pull historical stuff for, and Adam's got it here, for station 05BN012, which is Bow River. So back to the Bow River near the mouth. We're going to look specifically at the flood of 2013 that occurred in June along the Bow River. Actually, it affected quite a patch of Alberta. And if you're not familiar with this event, I'm going to provide a little bit more information about it, including a paper that talks about the weather event that caused it and then the hydrological implications of this event. Probably the worst flood event in Canadian history. There's another big one in the Saguenay River some years ago, but I think this one was a tiny bit worse. Again, how you quantify that depends, property damage, rate of flow in the river, whatever, but it was a big event. And so we're going to look at that. And what we're going to do is look at the data so this class will be handling the data, getting it in, getting it manipulated, getting it, having a quick look at getting a quick initial feel for the possible distribution that you're dealing with. And then we'll be using something called a QQ plot to have another closer look at the distribution. And we'll use the QQ plot with the proper distribution to derive what to derive a little equation that will allow us to predict or to estimate what the 100-year return flow value would be. And then we can place the flood event that actually occurred in context of, well, did that event exceed the 100-year event, or was it, almost the 100-year event, that sort of thing. So that's where we're going to go with this. So this is a nice, real world example. This is the sort of thing that many communities are very interested to hear. Like we saw the map of Calgary yesterday, where they had mapped, they had taken, okay, well, what's the potential stage, like the height of the river, for a given flood event, 1 in 100 year or whatever. And then they actually plotted that in a GIS, and then they go and make legislation based around that. So this, what you're going to see is the starting point for that process. And it has a lot of implications. You can imagine all of the property values. You can imagine what happens to a property value if it gets designated, it's in a floodplain or it's in a high-risk flood zone. If you own a house and suddenly it's designated a flood zone, well, the property value will collapse, right? So there are a lot of implications for this kind of work. So yeah, so we'll take a look at at how to manipulate, go and get, and then manipulate the flow data from a river, and then how to fit some of these, go about fitting these methods to perform estimations on it. So yeah, so Adam has got here where to get the data, and I'm going to, okay, we want the dailies. Thank you. Date format, CSV missing days, yes. Just for the one station, correct. Hopefully there was only one station that came up. There are a lot of stations in the hydrological database, thousands of them. So yeah, it's kind of a tough country to manage. If you think about, I sometimes think about, like, I don't know, the weather service of Luxembourg or Holland or something like that. Yeah, we've got a lot of terrain to cover, almost 10 million square kilometers. A lot of water features to monitor, as well as a lot of weather features. Dailies, daily data.
When you got it to plot, David, when I plot it, it does it exponentially. And it doesn't draw my line. I don't know why.
Does it exponentially?
Well, that it plots the. It's okay. I'm gonna try something else. Should work, but it's not.
So let's see. I'm gonna make a little thing. Oh, I forgot.
Ah, man.
Sorry, email. I tell you, it's interesting to be chair. Seeing under the hood of an organization like this. Okay, so what was I doing before? Just turn off the email.
Oh, yeah, I like that. Oh,
Nigel got in. Okay. Here, okay. What I think what people need is so read in the data, daily data for station. I think I should have it memorized by now. 05BN012. Is that right? Yep. 2. No Alzheimer's yet.
I figured it out. NAs, all these NAs. What a pain. Cool. It looks different than yours though, David. How do I do this?
What are you plotting? Oh, are you
So
doing the
did you-
histogram or are you doing a line plot over the years?
I'm doing the QQ plot.
Oh. It should be Gaussian by default. You can change the
No, I mean,
distribution.
when you showed me yours, I'll show you in a second here. I'm just going to send it to you because it's quite good actually. I'm just going to email it so it's not in the chat, as it were. I will share my screen, everyone, but let's practice bringing data in on our own, which is where we're at. It's dead silent out there. I know we've got a couple of people in the chat that said a few things. Thank you, but we're always welcome to hear your voices. Anybody struggling, questions, reminders, anything that they need, please do speak up. Always good. Otherwise, David and I'll just talk to each other.
Yep. And then start talking to ourselves.
Yeah. I'm happy with how that worked out.
Yep. Peyton,
Yeah.
yes. And I'm just writing kind of a tiny list of steps that you can take here.
So basically, Peyton, and this goes for everybody, the same things we've done almost every time, right? So what are those in recap? You got to load in your libraries. You got to then create a cell that brings your CSV into a data frame. Then you've got to make some considerations. Did it bring it in just verbatim? Do you have dates? Do you have date time? It's a CSV. So what are the hurdles we look at with the CSV? Are the headings there, comma separated, spaces, column names, all that good stuff? Does the data look reasonable? Do we need to index it on date? Do we need all the columns? All these questions that you got to ask about bringing in the data. We've gone through them all. They apply to every single data set. So the goal here is to go, again, straight from finding a data file online. We pointed you to this hydrological one. Bring it down to your computer, put it in the folder, new notebook, bring in your libraries, use our read CSV, our good friend there, set some parameters on the read CSV to get you into a data frame that's usable. And you've got a handful of methods to do that now. Pull up your old week 1, 2, 3, 4, 3, 1, 2, 3 labs, the notebooks I shared, whatever you need. There's lots of examples in there. And then I'm going to also send you this Pandas link, which you're familiar with the website by now because we've referenced it. whatever libraries you need, Peyton, to do what you're doing. Don't worry about any specifics beyond getting the data in. So if you need something for bringing the data in, we've been using Pandas, you'll need to import Pandas. If that's enough to do what you need to do, then great, you're golden. When we start introducing new things to you, we'll ask you to load those in. So here is the Pandas link. Just posted it in the chat. That will take you to the Pandas Box Plot page, and you should by now more or less understand some of the code on that page. It's the same way we've done df.plot for our line plots or scatter plots. We've done our histograms through Pandas, df.hist or whatever it was. So you should be familiar with the format. This is not Plotly. You're not having to build a figure, none of that higher stuff. This is that quick and dirty dot plot, close brackets. Pandas offers one that is dot box plot. And we want to try to run that as well. So give that a go with that link on Boxplot. As I say, that's kind of like step 4 after you've got your data, pulled your data in, data frame, figured out what you want in your data frame, does it look right, blah, blah, blah. Okay. Joey, has anybody got it in? I hope so. Anybody willing to speak up? If you're having particular syntax or can't directory issues or whichever, let's do a quick screen share or chat. Speak up.
Oh, no module named Panda.
It's Pandas. You forgot the S, unless that's just a typo in the chat. And feel free to copy paste out of your prior notebooks, out of my prior notebooks.
Yep.
It's a great reference. Yay, Pandas. Pandas are great.
I'm just having a hard time reading it in.
Okay, what's the struggle? What's the hurdle? What's not working?
I'm just going to copy paste and well, like when I'm trying to reading it in, I'm obviously not doing the right thing. I don't think so, anyways. This is how I got it saved in my actual directory, and then I write df equal pd read csv. Am I just missing the actual like how do you call that?
File type. So
extension.
The header and the use calls and the parse states?
Nope. So right now you're using Pandas read CSV and you've just got a string. Your file name actually has a, like Connor points out here, .csv. That's the actual file name. Like it could be .txt for a text file, or .exls for an Excel file. You're just missing the .csv. That should then bring it in.
Right. I tried that, but it did not bring it in either. It's telling me no such file directory.
So have you got the file that you're naming there in the same folder that you have created your Python notebook from?
Yes.
Are you 100% sure?
I'm in the same, because I usually do my my notebooks in my Geog 373 folder. And that's where I store all my downloads, all the data downloads. And it is in here in the same folder. And I try importing it, but it's not working. Let's,
David, if you don't mind, and others, if you've kind of maybe even taken a screenshot of David's notes on the screen there, maybe Joey, we can do a quick screen share. I'm also going to, while you're getting that, I'm going to look up week 1 here, because I think we had some notes on testing your directory, didn't I? Let's just see if I can find us. Maybe we didn't. Okay, and then scroll down a little bit, show us the there. Oh, such. Okay, so did you type in the file name or did you copy and paste it in?
I just typed it in because it's
So
right.
you got all the underscores, dashes, etc. correct? Because they're complicated in there.
Right.
Is he able to
Right.
right click and copy the, yeah, from there?
So it looks like you've spelled out March, but
Copy link. Oh, I see what I did. Oh, okay.
yeah, so it's just a typo.
Oops. Nope.
It,
Just take out CH.
yeah. Because the link might be more than you bargained for.
There you go.
Ta-da.
Right. So
Yeah.
it's those little things.
It is. It's totally. I mean, and that just comes with the more times
Oh, yeah.
you try it, which is kind of why we ask you to do what we're doing today, because you need to do it more and more times to see them. Because you're right, it just is the way it is.
Yeah.
The coding world
One period will stop the entire program.
forever, and the bigger and bigger and longer your code segments get, and you're like, oh, I got to the end of it, and then bing, something doesn't work. Scrolling through to try to find the error is a nightmare.
Yeah, that's why you want to build it up as you go. You never like code a whole pile of steps and then hit run, because if it doesn't work, it could be broken in a bunch of places.
And I work in SQL a lot and do lots of joins, and I'll do insert statements in one file that are referencing views in another, and the view has joins and so does the insert. So if the insert join doesn't work, then you got to now start going back to us. Joins on joins on joins.
I think people in the class are saying, I thought this course was in English.
Yeah. All right. How's everyone doing? Anybody found something interesting? Want to share column names, their data frames, things that they've had to copy and paste out of last week or a week before lab? I would give you the hint that you're gonna probably want to go back to week 2 for some CSV imports. All right, Kimberly, what looks so weird about it? Have you got your data frame in a fashion that the box block made sense?
Oh yeah, it makes sense. I just feel like it's kind of ugly.
Great. Well done. I mean, if you got it in, that's great.
Yeah, plot's a plot. Sometimes anything, it's like, oh, finally it did it. Is
Yeah.
that what you wanted, Maddie? Those notes?
Yeah.
My niece's name is Maddie.
So somebody tell me some interesting things about the CSV file when you brought it in. There are things to discover. So tell me, what did you discover?
I'm wondering, so when we're bringing it in, like for the last lab, we had to parse the dates, but in the CSV file, the date is in just one column. So I'm wondering if it's a similar kind of idea, bringing it in, if we have to parse the dates or not.
So what's a CSV file, right? We've kind of talked about this before. I mean, it's pretty basic. It's a text file. So everything's just a string of letters or numbers separated by a comma. So read CSV by default recognizes that comma is the delimiter. So it drops the comma and then puts the strings either side of the comma into columns in our data frame. Now, if we know that, even though the column header says date, does Python know it's a date?
No.
What does parse dates do for us?
We used it last week to like bring the different like year, month, and day together.
Mm-hmm. So do we need it if it is truly a date?
No, because it's in one, like it's in one column already.
All right. So have you tried that?
Just like without the parse dates.
Sure.
Yeah, I tried that.
And did it work?
Rather than. Yeah, I think so.
All right.
When I did
you manage to index on the date?
Not yet.
So just because we've used parse dates before, you're right. I mean, parse dates, we used it to bring together more than one column into a date, parse it. If it's already in a column, then we probably don't need to parse date. But if we put it in there, does it break anything?
Maybe. That did give me
I
an
think
answer.
you're on the
I just
right
thought
track.
Yeah.
You know, I wouldn't overthink these things too much. It's easy to just try these things, but isolate them. So only make one change at a time. So get it loaded in and either add the parse dates and then go, okay, well, do I need it? Just take it out and see if it changes something. As long as you're making one change at a time and starting from a point you know you can load, then you can try these things. Great, Rachel, thank you. Everybody want to take a look at that chat. Rachel has got the first big gotcha in the CSV file, which everybody will need to overcome. And there are more than one way to do so. Rachel has identified one of those. Okay. David, what are you looking for with the box plot?
Just the most, basic level box and whisker plot to show the, to get a sense of whether or not we've got a Gaussian or some other type of distribution. Is that what you mean?
Mm-hmm. But just thinking about what we know about the data, which the students may not know yet.
Well, one thing to
like
bear in
what
mind would be to think, what is a Gaussian? Once they see a box and whisker plot, what would a Gaussian distribution look like in that context? And then do the data look like what you would expect? Data, is it data? Rachel, is it data?
I think she means dates. So she's
Yeah.
So date and value in the use calls.
Yeah.
Sorry, I did mean data. I just meant like this, like CSV file, whatever the columns are named, not the one that we use from week 2.
Right.
Oh, I
Thank you.
see. Yeah.
Yeah. That's great. I'm trying to get my box plot going here too.
Let's see here. Erase who can get a box plot first.
Series objects are immutable, thus they cannot be hashed. That's a fun
I
error
love that
message.
one. I mean, that implies it's looking for a dictionary object, but I don't know why. Hashed.
I don't think my change is going to make a difference, but still. No. See, I don't know what you're. Yeah, see, it's not gonna. Kimberly, you said you got a box plot going, but it was ugly. What was
Yep.
ugly about it?
I don't know. I think it's just arbitrarily an ugly plot, but I don't know. Nothing terribly interesting. I mean, it just looks like a regular box plot. But
Mine doesn't look like a regular box plot.
do you want me to share what mine looks like, or?
Mine looks not right. Okay, well, we're getting into box plots. Maybe somebody wants to share their box plot.
Yeah, sure, I can if you want. Cool. Can you see that?
Right. See, this is what I was thinking, David, that should we should be splitting the data, right?
Well, what the QQ plot, so for just an aside about extremes, the analysis of extremes. So what we're wanting to do, or what is wanted to be done with this type of procedure, is we want to try to get an estimate of the maximum value that's going to occur. And the maximum value is always taken over a certain period of time. So one of the issues that you can imagine if we're doing something like this is we have, say, okay, so like say you want to do winds. So you have hourly observations of wind. And you want to say, well, what's the probability that we're going to get an extreme wind event? Okay, well, how do you define that? So you might have the winds are low all year, except say you had some, for a 2-day period, you had some huge storm come in. And so if you look at the wind speed trace, it's kind of low, low, low. And then for 48 hours, the winds are really high, and then they go back down again. Well, do you want to capture 48 hourly wind observations and fold that into the data that you're analyzing? Or do you want to somehow capture the fact that was one like synoptic wind event, that was one storm that drove that? So you have to kind of be careful about how you make a decision about what you're calling an extreme value. And so the way it's usually done, like for rivers and so on, is we just center it around annual. So we'll chop the time series into annual chunks, and we take the maximum value that was observed in that year, maximum daily flow value that was observed in that year. And then we have a subset. In this case, we should have 55 years. So we will have a sub data set of 55 hourly or 55, well, their daily maximum flows, one for each year. And so, yes, that's a box and whisker plot right there. So that's fine. But what we want to do now is to subset the data onto annual maxima and then run the box plot. I think then it's going to look a little better. So what the box plot is showing you though, so but I mean, it's useful to look at this. So when you look at this, does this look like a Gaussian distribution, that plot? Or let's say, what would a Gaussian distribution look like as a box plot, box and whisker plot? Yeah, so Julia says no. And why isn't it? I mean, that's correct, but why? What would you expect to be seeing?
You'd expect the box to like be in the middle of the distribution.
Exactly, that's right. So we would expect the box to be in the middle, and we probably wouldn't expect the tails to be nearly as long. So what this is saying, and the way the box plot works is, I mean, they're sometimes a little different, but usually the way they work is 75% or 50% of all of the observations are within the box itself. So it goes from Q25 to Q75. The mean is the middle line in the box. The two little bars are going to be like 5% and 95% of all the observations. And then the individual dots are the extreme values that go beyond the 5 and 95% range. So what we've got is a very definitely a long tail distribution. We've got most of the time, the river kind of chugs along at a pretty calm rate of flow, like under 100, never gets above 100. Sometimes, yeah, we see values that range all the way up to like 600. But by and large, it doesn't. So what people should do, I mean, get yourself a box plot, either on the daily data or on the annual maxima. Sorry, yeah, So just, yeah, just figure out the box plot. I mean, really, this is all it is because again, pandas, the data frame object has box plot as a method that will produce them automatically for you. So the real challenge now is to subset for the annual maximum value. And then run your box plot, see what you get. Oh.
So this request is suggested is a little tricky. Anybody remember how we might go about doing this? Well, David was asking about being able to subset the data to the maximum value per year. Has anybody got that?
Hey, Adam, could you just help me with trying to get that box plot in? Because it's like saying that data is not a column when I'm trying to put it in.
data isn't a column.
That's what it's saying, I think. Can I just screen share?
Sure, yeah. My box plot isn't working right now either because it requires things be in a pandas data frame, and the way I subset doesn't put it into a pandas data frame.
Can you see this?
Yeah.
Okay. It says like data.
You can't, you've closed your bracket for your read CSV, but you've added arguments. Your arguments are just hanging free. You gotta close, you gotta keep them inside. Remember? Does that make sense?
For where, sorry?
Well, you've got a line here, you've got DF, right? Your data frame equals PD read CSV.
Yeah.
And then you've got your open close brackets.
Yeah.
Well, that's it. But then on the next line, you've got skip rows equals 1. Well, that doesn't mean anything. That now is outside of your read CSV argument.
Oh.
So what you need to do is you need to take away that bracket. Yeah, how'd you do that, David? That's great.
I know. I was like, wow, you're on the screen.
Take
Get off my
that-
screen.
Take away that bracket and
Okay.
put it at the end of your arguments for your read CSV. Not there, David.
There.
Yeah.
Okay.
Oh, she had a comma there. Sorry.
Yeah, it does. She can get rid of the comma or leave it. Doesn't
There.
actually matter in this case. But
The comma does need to go there.
so you've got some invalid syntax because yeah, there you go. David says put a comma up there. That's correct. Try that. There we go. Okay, and I would just caution you on your notes here that clean up your tab alignment, what's going on, because it's very hard here to see that you've got those arguments inside your read CSV argument for your function. Do you know what I mean? Like,
Yeah.
just for your sanity, you break that out a little bit.
Bold
too.
of you to assume I have any, but okay. So then, okay, now that works. Is that how it's supposed to look?
Yep. And then moving on from there, what we're trying to do is subset our data frame by the max value per year. A single data set.
Okay.
It's more challenging. We have done it before, but it's going to take some digging. You can always Google it as well. It is still inside the pandas realm. Give it a try.
Okay.
It is more challenging. You're welcome.
Yeah, you can get it. I kind of discovered that this morning. You can get it at the top. There's, I can't see it now because the screen share disappeared, but there's a little thing that comes up with options. You can, a little drop down menu and annotate. You've got all sorts of little thingies that you can scribble. So.
Oh, on your thing, yeah. Did you realize that you had the box plot was a data frame? Well, that is a pandas, so it's therefore data frame dependent.
No, not necessarily. I mean, that's one way to do it.
There we go. Yeah, no, anyway, when I used the method you did to do the subset for max year, because it was just one value, the max, it didn't keep it in a data frame. So I had to put it back in a data frame.
Oh, I see. Yeah.
To get my box plot to work.
I find I'm using df.dataframe, everything in brackets.
Yeah, here's what I did.
Yeah, because it's often, whenever you're extracting a column, it'll switch it into a series or a list or something, but I want it back in a data frame.
Yeah, so I did it that way, but that was just for my sanity. Although I got to be careful because now I'm using the same. Yeah, I don't like that I'm using the same variable names. Let's fix that. Let's do this. Yeah, okay. All right, anybody figured out a way to get this data set from this CSV through to a max year value? Broke everything again. There we go. No? No one? Anybody want to talk it out?
I'm just still trying to find where we've done something similar to this before.
Mm-hmm. Good. David, subsetting it to max on year messed up my data set. It made my
Here.
histogram look. It made my histogram look better, my box plot look better, but not my QQ plot.
Oh, I don't know what to say. Let's see.
In my QQ plot, can I not just use everything?
Here, let's see. This is mine.
Okay, good question, Rachel. Okay, not sure how to separate the date into the year. Remember, we've been using the data frame.index.month. Last week, we also used data frame.index.year to pull out the year from our data frame index. So give that a try to get the year.
That got me that plot that you saw earlier.
Really? With the curve in it?
Yeah.
Mine isn't like that. Oh. The only difference I've done. No. Oh, now I don't have to do that. Okay.
So in that case, annex or annual X, it's just a series. It's not a data frame anymore. I'm not sure if you give it a data frame, it might not work. I think it just wants a series.
Oh, right. Huh. Gotcha. That probably isn't helping, is it? Hey, I got it back. Okay, good. Wonderful. You were correct. It was taking my dates and not my values. Okay. Anybody got some thoughts? I hope we're not just sitting there waiting for myself or David to pipe up. Okay, anybody got a lead that we can all discuss together?
Here we go.
David, did you want to talk about the param column before we
Yeah,
start this
sure.
subset?
Okay. So
And then we'll start talking about the subset. And Kimberly, I saw your comment there. So yes, I will come back to you.
so let me share my screen if I can find it. There it is. So I know everybody had a good look at the data in Notepad or something equivalent before you started. So what information is provided at the top? someone can speak up. Nobody's sure, even though it's printed down for you.
Something
Okay.
about daily discharge and daily water level.
Right. So it's basically saying we've got two variables here. How are they separated? Do we have a discharge and a water level column?
Looks like they're given a value of 1 or 2, depending on what they are.
That's right. So we've got two variables in the same column. So if you scroll down far enough, let us undertake that. Oops, wrong computer. So you see here, we've got times starting in 1964, parameter 1. Down we go. Oh, look, parameter 2 ends at 2019. So if you weren't paying attention to parameter, yeah, 2019, that's a good ending date, but it's a different parameter. So if we actually scroll up there's 1, 2018, slow mouse wheel, 2019, bang, there it ends. So right there, we've got a second parameter starting, an entire second variable. We don't want that. That's stage data in meters above bank. The previous is flow data, cubic meters per second, entirely different things. We don't want to mix those two things together. So the first thing that needs to be done is parameter 1 needs to be isolated.
And there's several ways we've learned to do that. The term for the way that we've done it most commonly is called masking or mask. So if we want our entire data frame where the data frame column parameter equals 1, you should be able to find a way to do that from our prior lab notes. Yeah, I even see it here. It is on my last, one of those ways is on my last Lab4 notebook I shared.
Oh, I see.
Very quiet today. So by now, all of you will have recalled that this that I'm copying and pasting into the notebook, sorry, into the chat, is from last week's notebook I shared. Okay, but it is the same method by which you can mask or subset our data set today. See if you can take that using the same method. There you go, Nigel, thank you. Same method to get only where the parameter is equal to 1.
Oops.
So you got to be careful. You don't want to take the max min of everything, because if you included parameter 1 and 2 and you're taking the max in a year, you're taking 2 different data sets, right? So you want to split them out before you take the max. Otherwise, your max won't be of flow or stage. It'll be the max between flow and stage. So the first step is to mask your data based off of that parameter value, 1, and then see if you can group your data by year to take the max value. So that being said, you've got what I just sent in the chat there for the masking. So hopefully you've had a chance there to find a way to make that work. From there, we want to try to get our max. So we want to get our yearly max. So we want to group our data set. So there is a function named group by in Pandas that will do it for us. So that would look something like this. So that would be our data frame group by function. Now, that's not going to do it for us on our own, right? So what did we say we wanted to group by?
Parameter?
No, we've already done that. We did a mask on parameter, right? So we've already split out our data frame to only include values where parameter equals 1. That was just taking all of them. We weren't grouping them. We were just subsetting. Taking a mask in this case was the method that I shared. Once we've done that, once we've got that flow data values only, then we want to group it by what? David and I were talking about this a moment ago. What are we going to group by? By year. Great. All right. So we want to group by year. So I was talking a little while ago about how do we identify, how do we get year from our data frame? That's great, Kimberly. Okay, well, hey, instead of seeing me just ramble, Kimberly, if you're willing to share screen, we could walk it through with what you've got so far.
Oh, that sounds delightful. Sure. Cool. Can you guys see this?
Yep.
Okay. Yeah, I don't know what to do to subset it.
Okay, so did that work for you?
No. Invalid syntax.
Okay,
for
so when
You're on the right track.
Yeah, it's close. So what happened when we worked with our
Sorry?
Actually, I'm surprised that didn't work. Look at your, show me the data frame. Yeah.
She's got one in quotes.
Oh, is that it? Okay, I thought it was the data frame. Yes. Okay.
that?
Yep. Why?
Because it's like a number, not letters, maybe?
Right. Number, not a string. You can have numbers in strings. But yes, it's not a text field, it's a number field. Okay, so there you go. So now if you look at df sub, yeah, now you've got it just with your parameter 1. And you can do the box plot there too. Yeah, okay. All right, so group by, all right, look at that, great, we're getting closer. So we've got our parameter subsetted data frame, and then you've got group by. Inside the group bys, you've got a string. And then we've got dot max. So great, let's talk about the dot max part. So the group by function groups, and then you have to have something after it. So you can do max, min, there's several other things. You can do an average. We want max. So absolutely correct here. Group by, open close brackets, dot max, open close brackets. Now, we need to put the argument inside our group by which we want the max. So we've already established that that's year. So scroll up just a touch.
I did it a couple times. I figured that this one was correct. I think.
Somebody muted me. The host muted me. David.
Same.
Oh, sorry.
Sorry. Here I am. Okay, so A that you've got there, you've got equals df.index.year, and then you went to print year, print A, and it printed the years.
Mm-hmm.
So that looks pretty good. So why don't we put df.index.year inside our group by? Like
Sorry,
you
can you
have
say again?
there. Yeah, great. B. Okay, so hit go there, and you got your B data frame. Great.
Mm.
There we go. Does that work?
Looked, yeah, I think so.
Looks great.
Cool. Kind of a bit messy, but
Not
Messy?
really.
No,
Pretty
it's-
good. You should see our code before I send it to you.
I don't
Yeah,
know.
holy
I
cow.
like all these things. Okay.
Okay, great. So everyone else listening in, can we go over that again from the beginning? Yeah, sure.
Sorry.
How about
Yeah, I'm sorry.
Well-
Mine it was a little chaotic, guys. I'm sorry.
that's fine. How about I do
No.
a screen share of the same thing that
Good
Kimberly just
idea.
went through with us, which is great. So I think I'm sharing the screen correctly.
Yep.
Okay, so just as I said at the beginning, we have load our libraries, load our data. Okay, done. Everybody should have gotten to that stage. I even made myself a little note here about parameter 1 and 2. Okay, here down here you can see that I've started to do my box plots as we asked you. But in this middle box, okay, I've done things slightly differently than Kimberly, but she got to the same point I did. So Kimberly, you don't need to change anything. But here, I am creating a new variable. I'm naming it df1. Named it, sorry guys, named it df1. And then what I did is I did the mask method, okay, which for most of you and for Kimberly, it looked like this, right? Minus one of those square brackets, which took your entire data frame and masked it by the parameter equals 1 in the data frame. All I've done here is instead of taking the entire data frame and masking it, I've just taken value. So if I run this cell, what df1 looks like is this. Okay, so it doesn't have any other columns. Technically, it's not a data frame anymore, but let's gloss over that for now. And we've still got our dates as an index, and then we've got our values. And this will only be showing us everything, every value in our original data frame that meets the requirement parameter equal to 1. Okay. From there, I'm going to create yet another variable, and I'm going to use my group by on this. So I'm going to take my df1, as you see below. I'm going to go group by inside my group by function. I'm going to call my df1 down here. The index, as you can see here, is date. And I'm going to look for the year out of that date specifically. I don't want the months or the days. And then I'm going to go dot max. I only want the max value of the groups of values for each of the years. And I'm going to assign that variable df1 underscore max. If I do that, my result will look like this. Again, not technically a data frame, but I have a column with my dates, 1 year per row, and then I have one value corresponding to that year. So this has given me the maximum value in any of the given years inside of our original data set. All right. Now, for the purposes of using some of the other plots below, for example, the box plot, I've chosen to take this variable output that is not a Pandas data frame and put it back into a Pandas data frame. So I've created a new variable, df1 underscore sub. And then I've used our Pandas data frame, which I think we used in Lab4. And then I've taken the df1 max variable. And when I execute this, I will get my data frame format back, where I have a value column and a date column indexed. And then I can use that in my plots. Okay, so we've got a couple of people saying that they have no attribute year. Ensure that you've got df, whatever your data frame variable is, dot index, dot year. And then if it's not finding the year, check your index. Have you set your index? You need to set your index to the date as you parse the date out. If you didn't parse dates, your index on date actually isn't a date. We kind of had this conversation, I think it was with Connor, and I said try it both ways. If you don't parse dates and you run it, you won't run into an error. It'll still index. But what it'll look like is, I'll show you. So see how the date here is year dash month dash day. If I take parse dates out, what it will look like, it won't let me do it there. Let's just do it here. What the index will look like. See how now it's year with slashes. That's right. But is this a date time format for Python, or is this just the string that had the slashes in our CSV? The answer is it's the string from the CSV, but it still to our eyes looks like a date. However, it is not a date time index. So we do, in fact, need to parse our dates when we bring them in, then set our index so that we get our date time index on date, so that we can use things like df.index.year. Okay? Great learning point. And thank you, Connor, for talking about that at the beginning. I think it was Connor. Apologies if it wasn't.
Whoa.
Okay, so however you got your mask, then you're going to do your group by with year and max. And then if you choose, you can bring it back to a data frame. These two are not mandatory to do them in the same method I did. Once we've done that, for parameter, Rachel, do you have it as a 1, or did you have the same thing going on that Kimberly did? And you got to make sure that you're either in quotes or just dot param. Got it. Great. Okay, so I'm going to drop this cell. So I made my 3 variables here. The way I've chosen to do it means I result in a data frame subset based on parameter 1 by max year values. So I can take that and throw it straight into my, oops, don't do it that way. I can don't need to do that because it's data frame. I can just throw it straight onto my histogram, and it will print my histogram. Okay. And likewise with the box plot, I can just go, because now I'm in Pandas data frames, I can just use my df1 sub data frame, call the box plot, and I will see my box plot. All right. Questions on that? Is everybody starting to follow in the, we've done this a few weeks in a row now. It's starting to become a little more familiar, even though we still run into syntax. I do still all the time. But you start getting a little bit better at recognizing them and then hunting them down. Okay. So, questions on that? Most people caught up. Second data frame, Maddie? We don't need a second data frame. We don't need to look up parameter 2 currently.
Yeah. And you'd have quotes around param as well.
Yeah, if you're calling it that way. Okay, so that's great. Should we, David, keep plowing in and get to the QQ plots? Or did you want to talk a little bit more about some of the other stuff?
Yeah, I was just wondering if we should maybe call it for today. Because I know, they've got an extension for the lab. People
That's
probably
true.
want to get on with that. And I think I should prep a little bit of context for these with some more examples of what they look like. So I think we'll do that. So I think we'll call it for today. People don't have more questions. If you've got questions, just stay on. But if not, yeah, we'll call it good for today and let everybody go. I'll
Hey,
stop.
Adam, oh, sorry.
It's okay. I'll just stop recording. So
go ahead, Sarah.
I was just hoping to share my screen. I'm pretty much caught up. The only thing I'm having the same error that you just went over, but unfortunately,
That's okay.
I was